Academy. This is integration. You look at integration, change of variable method. Previously, we have been looking at different types of methods of integration, special forms. So if you have not subscribed to this channel, can subscribe and share with your friends also. So welcome to this today's tutorial. And if you have a comment, leave it down there as a comment. And if you have a question, again, leave it like a comment. Okay. So this is one of the integration methods which simplifies some of complex equations like this one. If you have integration of sine 4x, and if you check this well, you see that our general integration for sine 4x, for sine x, you expect to be a negative cosine x. But it's not very direct to do the integral of sine 4x. So if you look at this one, you find that you need to do some modification. Let's look at this example here and let's see how we play with it. So we have sine integral of tan root of x of root x. So in this case here, because here it's saying change of variable, so we are going to change the variable root x to t, so that we can write this one, get the because you are saying the t, let me change color, we are saying t is same as x power r. So if we integrate this to get dt and dx, integrate t in respect to x, t in respect to x, then we get this one. So if we rearrange, we will find that our 2 dt is equivalent to this. So that our equation now, we can write it as integral of tan t by 2t, which was x over root x. So that we can now be left with a simplified form of this 2 root tan t dt, which we can be able to integrate. We know this one from our general integral. Tan of t will be given as ln sec of t. So ln sec of t. But we know our t here is root x. So after substitution of t, you get this is now the correct integral of the solution of that. So let us do this one together. So in this case here, we have this kind of equation here. So you need to see which one will be able to change to a variable 2. Remember, if so far you have not subscribed to this channel, kindly subscribe and share also with your friends. If you have any question of what you have looked previously, you can leave it down there as a comment. I will be glad to check it out. So here, in this case here, we let our t to be 1 minus x squared. So that our dt, integrating t in respect to x, we have negative 2x. we get negative 2x. I think this shouldn't be, our equation here should be this. We change this one to 3. Change this to 3. We change this one to 3. So that it gives us our proper equation. So we make this one 3 to power 3. Okay, we put this one 0, so this becomes 3, so that this is to power 3, so that our equation makes sense here. So this will be 3 squared. Yeah, we wanted to have some of it here, so that was some help there. Okay, so this means that our dt, you can say 1 over 3 advant of dt is same as x squared dx. So you can see this is actually a combination of this and this. So next, if we substitute, you'll find that we are having now the integral of root t. The root of t is like t to a power of half. You know that. And then x squared dx is actually 1 over 3 advant of the dt from our discussion there. So that's what we are calling change of variable. We have changed our variable from root x to t, and then our integration becomes simpler. When it becomes simpler, then we are able to do the manipulation. So you can see here we have 1 over 3 integral of t power 1 over 2 which is half dt. You see, now it comes a very simple and doable calculation, and you can see if we integrate this, you are going to find to get 1 over 3 we get negative 1 over 3 times 2 over 3, because you know what happens in direct integration. 2 over 3 t power 3 and 3 over 2. So you can see this, and now the answer to this question here becomes negative 2 over 9 t. Remember our t now is root x, so you can bring back our 1 in t 1 minus, is our t is 1 minus x k cubed, x cubed. So we know that, and all these to the power 3 over 2, and then plus a constant, because obvious, if you integrate you expect to have a constant. So basically this is our solution to this. Sometimes it happens that we suppose that our equation here ends some integrals. Some integrals. But I think this is not a tip that you can leave it for next time. And make sure you subscribe to this channel, because if you join to this channel, we both get to support each other, and we also get to get a good time. I'm going to launch live streaming for either of the topic, and sometimes you can get several questions that look alike. What I do, I make online live stream, and we will be able to discuss this together, getting views from each other. Remember, we get to know by sharing knowledge. And now, to this far, make sure you subscribe, okay, subscribe, and don't forget to share. That's what you are saying, subscribe and share. Until next time, if you have a question, leave down a comment, and I will be able to check on it. Remember, this is the Epic Academy. Bye until next time.